Good morning. Today we will be dealing with digital to analog conversion and why we need the conversion from the digital data to analog data. So we know that the data available in the computers will be in the form of digital, and we will be passing the data through the physical wire in the analog form. So that is why we need the conversion of the digital data or digital signal to analog data or analog signal. So to send the digital data or an analog media, it needs to first need to be converted to analog signal. So this is how you will be representing them. When a data from one computer is to send to another computer via some analog carrier, it first should be converted to analog signal. And analog signals usually will be characterized by amplitude, frequency and phase. So in this figure we can see that there is a center, and center will be having data in the digital format, and this mode that will be applied to the modulator, and this modulator will convert the digital data into analog signal. So that analog signal will be transmitted to the physical carrier, and then we have a demodulator at the receiver end which will be receiving the data in the analog form and transmitting the analog data into digital data required by the receiver. So this is the overall block representation for the digital to analog transmission. So now, as we know that there will be three characteristics for the analog signal. They are amplitude, frequency and phase. Now we can see each of them in detail. So amplitude, and if we are changing the amplitude of the analog signal for transmitting the data, then we say that it is amplitude shift keying. And if we are changing the frequency of the analog signal, then we say that it is frequency shift keying. And then if we are changing the phase of the analog signal, then we say that it is phase shift keying. So this is the block representation. So you will be having a digital to analog conversion, and that conversion can be occurs in three ways, that is amplitude shift keying, frequency shift keying and phase shift keying. And this amplitude and phase shift keying both can be joined to form a quadrature amplitude modulation QAM, which will be discussed later. So in this topic you will be dealing only with amplitude, frequency and phase shift keying. So now the first one, which is called the phase shift keying, and we know that we already said if the amplitude of the analog signal is modified to reflect the binary data, then we say that it is amplitude shift keying. So here this is the pictorial representation, and when a binary data represents digit 1, amplitude is held. So if 1 is the binary data, then the amplitude of the signal is made as high, and if 0 is the binary data, then the amplitude is held to 0. Okay, and here we see that the frequency and the phase of the signal will be remained as same as that of the original carrier signal. So this is how you will be represent. The amplitude will be changed to represent. So this amplitude, you will be having a high amplitude means it represents 1, a low 0 amplitude means what? It represents 0. So this is the amplitude shift key. And the next is the frequency shift keying, and here the frequency of the analog signal is modified to reflect the binary data, and here we will be using two frequencies, F1 and F2. Okay, so this is frequency F1 and this is frequency F2, and one frequency is used to represent a binary 1, and another one is used to represent a binary 0. Here both the amplitude and phase of the carrier wave is kept intact. That is, here we can see that amplitude is same for all the signals, either it can be 1 or a 0, amplitude will be same, and here also the phase is also the same. So when we start a signal, it will start from this, and here also it will start from this. This phase will be same, but only the difference is the frequencies. So here the frequency is this may be used to represent 1, then it may be used to represent 0. So this is 1, this is 0, and this is again 1. So two frequencies are used to represent the binary 1s and 0s. And next is the phase shift keying. In the case of phase shift keying, the original carrier signal's phase is reflected, or phase is changed to reflect the binary data, and when a new binary symbol is encountered, the phase of the signal is altered. Here, so here if 1 is represented like this, okay, and it comes here, and if 0, which is a new binary data, which is not similar to the already available one, that is 1, it is a new one, 0 is a new one, that is a change occurs in the binary data, then we need to change the phase shift. So here we know that this is changing. And again, if 1 comes, then also the phase will be changing, and that comes here. And again 1, which is not a new binary data, which is the already existing binary data, which is not a new binary data. So here the phase will not be shifted. So it comes here, and then 0, again the phase should be shifted. So this is how. And here also we can say that the frequency is not changing and amplitude is not changing, and that is called the phase shift keying. Thank you.